Welcome to This Explainer. Today, we're diving into a really fascinating paradox right at the heart of the renewable energy transition. We usually picture solar power as completely clean and limitless. But what about the massive industrial muscle required to build those panels in the first place? Today, we're uncovering the hidden economics and the intense energy demands of manufacturing the very technologies that are supposed to save our planet.
So let's kick things off with a question that, honestly, most of us probably never even think about when we see a shiny new solar panel gleaming on a rooftop. How much energy does it actually take to manufacture clean energy? It sounds a bit like a riddle, right? But it's actually one of the absolute most critical challenges facing the solar tech industry today.
We tend to just assume solar panels are 100% clean right out of the box. But the reality? The manufacturing process is incredibly energy intensive. We call this the green paradox. Building these essential transition technologies, mining the silicon, melting it down, assembling the photovoltaic modules, it literally requires a massive amount of traditional electricity. And a whole lot of that is still bought directly from standard fossil fuel-heavy power grids.
To get a real handle on how the industry actually measures all this, we're going to look at the Sustainability Accounting Standards Board, or SASB framework. Specifically, we're looking at their standard for solar technology and project developers. This framework tracks exactly how the industry operates behind the scenes, giving investors and companies a standardized way to measure sustainability risks, including exactly how these factories manage their immense energy appetites.
Now, what's really interesting here is that SASB doesn't just accept some vague sustainability pledge. No way. They demand hard data on three very specific metrics: the total amount of energy the company consumed, measured in gigajoules, the percentage of that energy pulled from standard grid electricity, and the percentage that came from renewable sources. This data trio basically tells you everything you need to know about a manufacturer's operational resilience.
And just to be clear, when the standard says total energy consumed, we aren't just talking about keeping the office lights on, we're talking heavy industrial lifting. This includes energy from absolutely all sources. It covers direct fuel usage, all purchased electricity, and the energy required for heating, cooling, and the steam directly consumed by the factory during the reporting period. It's a complete, comprehensive footprint of the entire manufacturing operation.
Section 1, the weight of electricity, focusing on grid dependency and production costs.
As you can see, electrical energy purchased from the grid makes up a massive share of total production costs for these manufacturers. And think about it, when a single input takes up this much of your budget, any fluctuation in the price of that input can absolutely make or break your profit margins.
Because they rely so heavily on the grid, traditional solar manufacturers are actually in a pretty precarious spot. They're highly exposed to rising global energy costs. Plus, there's mounting regulatory uncertainty around the future of fossil-based energy. If a government suddenly slaps a heavy tax on carbon emissions, the cost of standard grid electricity could skyrocket, which would be devastating to a solar panel manufacturer's operational costs.
Moving on to Section 2, managing price volatility and finding that competitive edge.
So how do these companies actually survive this volatility? Well, according to the SASB standards, the playbook is pretty straightforward, even if it's tough to execute. Diversify energy sources, minimize overall grid reliance, and maintain a highly reliable supply. Doing all this is what allows them to achieve competitive pricing. And in a cutthroat market where buyers are constantly hunting for the lowest cost per watt, this kind of efficiency is literally everything.
When you compare the two different operational approaches side by side, the contrast is just stark. A traditional manufacturer is overly reliant on fossil-based grid energy, which leaves them wide open to market whims and price volatility. On the flip side, a diversified manufacturer strategically integrates clean, on-site renewable energy. This isn't just a feel-good environmental move, it's a hard-nosed, crucial financial strategy. It minimizes financial risk and directly translates into a massive competitive advantage.
Notice the dramatic drop in risk exposure here. By generating clean energy directly on-site to power their own manufacturing, a solar company effectively insulates itself from systemic disruptions and sudden price spikes in the broader energy infrastructure. They essentially lock in a portion of their energy costs, fully shielding themselves from the turbulent fossil fuel market.
Let's look at Section 3, the advantage of renewables and the rules of the game. But what actually counts as a renewable source under these strict industry standards? Well, the SASB framework defines it as energy from sources that replenish faster than they deplete. So we're talking geothermal, wind, solar, hydro, and biomass. Though, a quick side note, biomass has to be certified to a third-party standard to guarantee it's truly sustainable.
Now, here is a surprising but absolutely critical fact about how this accounting actually works. Let's say a factory generates its own solar power on-site to run its machines. They can't just automatically slap a 100% green label on it. To officially claim that renewable energy in their metrics, they have to retain and retire the associated renewable energy certificates, or RECs. They cannot sell those certificates to another company looking to offset their emissions. If they sell the certificate, they sell the right to claim that green energy. No double dipping allowed.
To wrap up this explainer, I want to leave you with a pretty provocative thought. As we rush to build this sustainable future, we really need to look closely at the supply chains making it all possible. Is the true test of the energy transition not just where our energy comes from, but how we manufacture the tools to harvest it? The companies that figure out how to build clean energy using clean energy won't just be saving the planet. They're going to be the ones dominating the market. Thanks for joining me today, and I really hope this changes how you look at the hidden economics of solar power.